Hey guys, Mr. Pavnik here again. We're looking at number 4 on the checkpoint practice for power series in Euler's approximation. In this problem, we're looking to use Euler's approximation method to find the value for y of 1.3. We're given dy dx as a differential equation, right? We're given an initial value or initial condition. We're given our step. Delta x is 0.1, and we're just going to go ahead and apply all those rules to get through here. So the first step here is to set yourself up a nice table that's going to help organize all your work, right? So you've got your y, your x, your dy dx, and then your equation. Okay, so what you're going to do with this stuff is you're going to always start out with your initial condition, right? And so the best thing about dy dx is it's actually slope, right? And so for your initial condition, when you have 1 for x and 2 for y, you can actually figure out exactly what the slope is at that point, because the slope depends on both y and x, right? So if I'm plugging 2 in for y and 1 in for x, I would get 3 for my slope, right? Because 2 times 2 is 4, minus 1 is 3, right? So what we're going to use for our equation is basically point slope form, right? So normally we would have y minus y1 equals m times x minus x1. Instead of y minus 1, we're going to add that y1 way out there at the end, right? So you've got y equals 3 times x minus the x value, and this is where we're adding the y value, right? So each of those things, right, your 1 came from the x initial condition. It also got dropped right there, right? Your 2 was given as the value of y when x was 1, right? You're also putting it here. And then this slope, this 3, is actually coming from the derivative at that point, 1, 2. Right, so all of those parts come together to get you that equation, and that's really not an approximation. This is the given condition that when x is 1, y is 2 for that function. And what we're going to try to do is try to predict the value of y past that. And so the first prediction is going to use this equation, right? And so our x, if our step is 0.1, we go from 1 to 1.1. Right, so the way we find our value of y, we're then going to take this x and we're going to drop it right there, right? And that's how we're going to find the y value, the approximated y value when x is 1.1, right? So we're doing 1.1 minus 1, that's 0.1. 3 times 0.1 is 0.3, and so our y value then is 2.3, right? So you can kind of see where this is going. So then if we need to get the value of dy dx, again, we're going to plug our y in here and our x in there, right? So 2 times 2.3 is 4.6 minus 1.1 gives us 3.5, right? So we've got this new slope, y equals 3.5. X minus, well, now x is 1.1, right? And what are we going to add? We're going to add the y value. Right, 2.3. So now we've got this new estimator, right? We know we're not quite right here, but it's the next best estimate, right? So if we step by 0.1, we're now at 1.2. If you plug in 1.2 here, 1.2 minus 1.1 is 0.1. 3.5 times 0.1, 0.35. And if you add 2.3 to 0.35, you get 2.65. Right, and so now we've got this new point, 1.2, 2.65, and we're going to use that up here to try to figure out what the derivative is. So 2 times 2.65 is 5.3. We're going to subtract off 1.2 and get 4.1. Right, so that's our new slope. So we got y equals 4.1, x minus the x value, 1.2, and then, of course, we're adding on our y value, 2.65. right? So the last thing we have to do, we're trying to approximate y when x is 1.3. So we're almost there, right? So we get to here, 1.3. What I like to do is just go like this for my own well-being. I mean, I could use it if I need to, but there's so many times that I get to here and I just start doing more than I need to do. So this is what I'm really looking for, right? The y value when x is 1.3. So I'm plugging in 1.3 here, right? So 1.3 minus 1.2 is 0.1 again. 4.1 times 0.1 is 0.41. And when I add 0.41 to 2.65, I get 3.06. So there it is. My approximation using Euler's method, when x is 1.3, I think that y will be approximately 3.06. Hope that helped.